In this video, we're going to look a little bit about how to write things in expanded form from sigma notation and expanded form to sigma notation. So let's start off with sigma notation. And you want to think of this as a counter. K is starting at 1 and going up to 5, and we're going to insert this number into here. This tells us what to do. And then it goes up each time. So we start with k equals 1. So our first term is going to be 1 squared plus 2. And then for our next term, we put in a plus. The sigma means a product, a sum. Means we're going to add each of these individual terms. Now the counter goes up to 2. And we get 2 squared plus 2. Now the counter goes up another one. It goes up to 3. So our k value just keeps going up 1 each time. And the top is going to tell us where to stop. The top stops at 5, so this is going to be our last term. So now we can sum these up. We have 3 plus 6 plus 11 plus 18 plus 27, and so our sum is going to be 65. So that's writing it in expanded form. Let's do another one for a little more practice. Doesn't matter what letter we use here. As long as these match, this tells us this is what's going in for I. So I is starting at 3 and ending at 6. All right. Now you might think at first that means there's 3 terms. Watch what happens. Our first term is 2 times 3 minus 1. Now that's going to keep going up 1 until we get to 6. 2 times 4 minus 1 plus 2 times 5 minus 1 plus 2 times 6 minus 1. Now look at that. There's 4 terms, because remember, this is one of the terms. When we do subtraction, we take a number away. We have to add in the term where I equals 3. So that's why there's 4. And so our numbers are going to be 5 plus 7 plus 9 plus 11 for a sum of 32. Now, what about going the other direction and writing it in summation notation? First thing you want to do is you want to identify some kind of pattern here. So what I see is it's going up by 2 each time, and it's starting at 3. So my general term, 2n plus 3, because I've got a linear relationship. It goes up by 2 each time, and it ends at 3. Now, where do I want to start? Well, with this that I built, I got to figure out what I want my bottom index to be. Well, I want to start at 0, because when n is 0, that's when this thing comes out to 3. When n is 1, I get, oh, excuse me, it's going up by 4 each time. My mistake. And when n is 1, we get 7. When n is 2, we get 8 plus 3 is 11. When n is 3, we get 15. Now you also have to tell it where to stop. So that's going to be where 4n plus 3 equals 27. Solving this for n is going to give you 6. So what we see is that there's going to be 7 terms in this sum, starting at 3, ending at 27, going up by 4. So there's our summation notation. Let's do just a couple more. One more time going from expanded to summation notation. So once again, we need to find an expression that does what this is doing. Well, what's happening is our numbers are doubling. 2 times 4 is 8, 8 times 2 is 16, so they're doubling each time. So we have an exponential situation, and if we wanted to build a function, we might do, let's use a different variable this time, 4 times 2 to the x. Okay, so we're going to use x in our summation notation, because we can use any letter we want. We just have to make sure it's represented down here. Now again, we want to make sure that this starts at the correct place. We need to start it at 4. That means x needs to be 0 to make sure that happens. Now we want our last one to be 256, so we need to find out for what value of x 4 times 2 to the x equals 256. And we just solve this. We divide by 4, and we get 2 to the x equals 64. And that's going to happen when x equals 5. So we had a expanded sum here of 6 terms, and that's writing it in summation notation. Again, any letter here is fine as long as they match. Last one, we're going to just write it, we got it in summation notation, we're going to write it in expanded form. So 1 over 2 to the first, I is starting at 1, and it's going to go up by 1 each time. And what we'll do at the end is we'll add all these terms up, and if you go ahead and do that, what you're going to find is you get 63 64ths. So this has just been a little bit of a demonstration on how to handle summation notation.